Okay, so for my first contribution to the week 5 discussion, I want to talk about alkene addition reactions, which is really the meat and potatoes of what we're going over this week. And in particular, I'm going to be doing a problem that involves halogenation. But before I do that, I wanted to just recommend one of these summary sheets to you folks. A chemistry tutor put me onto these, and ever since she has, I really started to like them. I found myself more and more being able to recall in my head what I've seen on these sheets when I'm doing a quiz or homework, and I just find them really useful. There's a couple different ways you can obtain one. You can borrow one from online, like I did. I went to chemistrysteps.com and grabbed one, and I will share this link for whoever wants to use this and study from it. But in addition, you could also make your own. You can, just pull up Google Docs or whatever and start making your own, or even Notability, I guess. And that serves a couple different functions. Number one, it helps you to cement the ideas via active recall. You're actually retrieving that information from your brain, but you're also, you're also reviewing the information at the same time, which is really helpful. This sheet has the majority of what we learned this week in Dr. Kerr's lectures, so I think it's a good one. There might be one or two things missing, but the vast majority of what we learned this week is in this summary sheet. So I will post that once I am done with this video. So let's move on to the problem. Let's zoom in here. Actually, let me grab my little pen tool. So you can see that we have a butene here, and then we have a bromine. And the question asks, provide the product formed in the following alkene reaction. So it has a bromine. So let's first talk about that for a second. One thing we learned in this week's lecture with Dr. Kerr is that this bond between the bromines is exceptionally weak. So it doesn't take a whole lot to break it. So what's going to happen is the double bond here is going to attack one of these bromines, and it is going to kick off the electrons onto one when it takes the other. Now, I realize that, seeing this in bond line structure, it can get a little confusing because the two carbons look like they're far away. So I'm just going to redraw it like this. So the double bond is broken, and we have the bromine right here, and it has formed a bond. Sorry, I'm a little slow with the pen here, with both carbons, and this creates basically a strained ring, which I'll abbreviate with SR. I should probably put the positive here as well to indicate that. Okay, so we have our CC bond with our strained ring. Now, this is not very stable, so the bromine over here, the minus bromine that was kicked off over here, this will attack from the back, because keep in mind that these wedges are coming out at you. They're pointing at you. So it can't come from this way because this way's blocked. This way's blocked by these wedges. It can only come from the back. So it's going to come from the back, and one of these will go away. Let me get rid of this. And instead, sorry, I'm not too good with this software. Now we will have a dash with a bromine. So if we were to convert this to a bond line structure, we would still have our, well, what is now a butane because the double ring is gone, except for one of them will be on a wedge and one will be on a dash. And that would be the final answer. Let me get rid of this just so it's not a little confusing. But to summarize, the double bond attacks one of the bromines, kicks off the electrons onto the remaining bromine, making this minus and this plus. This creates a strained ring between the two carbons, and then a bromine minus attacks from the back because, remember, the front is totally blocked by the wedges coming out, and that makes this go away, and it becomes a wedge in the front and a dash in the back, or vice versa. This is a racemic mixture, so it would be 50% this and 50% the opposite. So I hope that was helpful. And I almost forgot to actually answer the question itself, which is, if we look at our answer problems, the only one that matches what we drew is this right here, A. As you can see, it didn't take into account stereochemistry, but we know our stereochemistry is 50% this and 50%, wedge in the back, dash in the front kind of thing. So our answer is A. Check answer, and it is in fact A.